The next DAX function that I want to talk about is all. Now, the all function either returns all the rows of a table or all of the values within a column, completely ignoring any filter context. So here's what it looks like. The first argument of the function is either the table name or the column name that you want to clear filters on. Another way that I like to think about this is all is basically a remove filters function. So you could point to the entire sales or transactions table here, or specify a column like product category from your products table. And keep in mind here that all does not return a single number, it returns a table or a subset of a table. So you'll almost never use all by itself. Instead, you'll use it as a component of other functions, most commonly calculate. Now, the second optional set of parameters or arguments here are column names. So let's say you've selected a column as your first argument as opposed to an entire table. You do have the option to list additional columns here that you'd like to remove the filters on. The catch is that all of these columns must be fully qualified and include the table name, and they must all come from the same table. So, pro tip, instead of adding filter context or changing it like calculate does, all removes it. And that sounds a little bit confusing and potentially counterintuitive at first, until you realize what it's commonly used for, which is when you need unfiltered values that you don't want to react to changes in filter context. So a great example, which we're going to practice, is a percent of total calculation, where your denominator, your grand total, needs to always remain fixed. All right, so let's head over to Power BI and we'll give this a shot. Back here in the report view, I want to practice adding two new measures using that all function. But again, we're not going to use all on its own, we're going to use it as part of a calculate function. And the first one that I think we should add is a measure to capture the grand total of all orders across the board. So that way we can take our existing measure, the total orders measure, and then take the ratio to calculate something like the percent of grand total. So let me show you what I mean by that. We'll right click, we'll create a new measure. All right, and we're going to name this all orders. And we're going to start this off using our calculate function. And then the expression that we want to evaluate here is our total orders. And so far, so good. Everything is very similar. Here's where things get a little bit different. We want to return down another line, and we're going to enter the all function. So for our filter parameters here, calculate, remember, they can accept filter context like country equals USA or quantity is greater than 1, right? Simple Boolean filters like that. But it can also accept tables. So all returns a table of data. So what we want to do here is basically say, hey, and we want to remove all of the filters from our sales data table. So we'll close the parentheses on all, return down, and then close the parentheses on the entire calculate statement. So just to recap here, we want to say calculate my total orders in a modified filter expression where I am removing any filters applied to my sales data table. Right, so that's the way to interpret this. And again, because we're using all here, this will always return the grand total basically for my total orders. So let's lock this in and we'll add it to the matrix to see what's going on. All right, so our matrix visual here, I'm going to quickly clean this up and change this back to our category name. Right, and I can probably remove my bike returns, bike sales, right? I don't need those same repeating values. Same thing with my bike return rate. So let's go ahead and we'll add in total orders. Just for fun, we can add back our weekend orders. And now here, let's add in all orders. And come back, we'll make sure we format this. All right, we've got this all orders measure, and it is returning the same exact value for every row of this matrix, regardless of that initial filter context, right? So again, what all is doing in these cases is it's saying, hey, I want to calculate my total orders, and then I'm going to remove any filters that may be applied to my sales table. Well, based on this filter context here, right, you've got category name coming from your product lookup, filtering down into your sales table, and it should be filtering your sales table down to 16,983. But because we've added all, it's saying, nope, don't do that. I want you to remove any filters that have been applied and then just return my total orders measure. So that's what's happening here. So again, there isn't a real circumstance where you'd want to drag this field into a visual and analyze it by itself, right? It doesn't tell you much, again, beyond that total value. But where this does become useful is serving as an input for something like percent of all orders. So let's go ahead and we're going to add another measure. And like I just said, we're going to call this percent of all orders. And here, instead of using calculate, all we want to do is we basically want to divide our total orders by all of our orders, right? We want to use all orders as that denominator. So our numerator here is our total orders. Our denominator is going to be all orders. And then we don't need to add an alternate result here. So we'll lock this in. Make sure to format this as a percentage. And then once that's been added, we can now select it and bring it into the visual. Percent of all orders. So now this is so much more interesting and so much more valuable. And if we look at this column, our total adds up to 100%, which is correct. And now I can see some really interesting insight, like what percentage of the total orders do accessories account for, right? And you can see that it's, almost 67.5% of our orders contain accessories, right? 55% contain bikes, almost 28% for clothing. So it's already providing some pretty interesting insight. And now as a little added bonus here, even though all orders is a component of this percent of all orders calculation, right? It's the denominator. It doesn't need to live here in the matrix in order for us to calculate this percent of total. So if I were to remove all orders here, this function still works exactly the way you would expect it to. And it can still be filtered and segmented in any way that you could imagine. So that's a very common example of how to combine, calculate, and all to create these types of percent of total fields. So we're going to do one more quick demo here. And for this one, I'd like to calculate the average retail price or the average product price across the entire table, which will essentially give me a single number that captures the average price across my entire product set. All right, so we'll come back to our measures table. We'll add a new measure here. And we're going to call this overall average price. And you may remember that we've already calculated an average retail price just using that basic average function on its own. So now what we can do is calculate that measure, average retail price. And since we don't want the average retail price to change in reaction to our filter context, we can add in all and then basically say, hey, we want to remove any filters from our product lookup table. All right, so we'll close this out. And again, just to recap here, we want to evaluate our original average retail price in a modified filter context where we're removing any filters on the product lookup table. All right, so this is locked in. We can add this into our matrix and we'll take a look at what it's returning. All right, so let's do this, and we're actually going to add in our average retail price as well. And we'll just drag these to reorder and expand a little bit. Perfect. Now we can see how this is working in our matrix here. We've got our original average retail price that we've just pulled in, and then we've got our overall average retail price. And you can see that our overall average, which we use that all function for, gives us the same total average. It's all 714, all the way down through the total. And that's as expected, right? And what you can also see, what's pretty interesting here, is insights like our average retail price from accessories is way below our overall average price. For bikes, it's double, right, what our average retail price is. And then same thing for kind of clothing, same kind of insight there as accessories. And then components are a little bit closer to our average overall price there. So again, when you blend all of this together, you get that overall average retail price of about $714. All right, so we're going to be using this overall average price measure as a way to demo another function that's commonly nested with calculate, which is called the filter function. So stay tuned, that one's coming up next.